Hi and welcome to another video tutorial. This one's about aperture as it relates to digital photography, and you'll sometimes hear aperture referred to as f-stop. So that's what our video is about today. So I'm going to start out with some photographs of an actual aperture in a lens. So first thing to know is that an aperture is inside the lens. It's not part of the camera, it's part of the lens. When you change lenses, you'll get a different selection of apertures that you'll be able to select. So it's part of the lens, and obviously here on the left we've got one that's a wider aperture. Same lens, I manipulated the mechanism a little bit and showing it with a smaller aperture. So that's what you're looking at there is the light spot in the middle. It's very much like the pupil of your eye. It's able to control the amount of light that comes through, and that's what the aperture does in your lens. It's just like in the pupil of your eye, a larger, wider aperture lets more light through. So that's where the aperture is. It's actually a series of blades that overlap and can shrink down to make a small circle or a large circle. So that's what an aperture is. And what it does is it controls exposure for us. It's one of three things that controls exposure, which we mentioned briefly in the exposure video. So it's one of three things. And so a larger aperture lets more light through, and the smaller aperture lets less light through. But how are these things described in the camera? Well, I've got another picture here that shows the front of a camera lens, because remember the aperture is in the lens, and you'll see different numbers on the front of camera lenses. So one of the numbers is going to be the filter thread size. I haven't shown that here. These other two numbers are the focal lengths, which amount to the zoom range of the lens. But the important numbers are going to have a 1 colon in front of them, and those are the ranges of aperture sizes when they're at their largest. And what you'll notice here is there's always going to be a 1 in front. In this case there's a range of sizes depending on what the focal length is, because this is a zoom lens. Not all lenses will have a range, some of them will just have a single ratio. And so one of the important things that I mentioned there was that this is a ratio. So I'm going to write that down. It's actually a ratio of the diameter of the open aperture to the focal length. And because it's a ratio, that means that a larger aperture is also a smaller number numerically. So when we talk about larger, we're also talking about a smaller number. I'm just going to put this little hash mark to indicate that's a number, or the f-stop. So a smaller f-stop is actually a larger aperture, physically larger, lets more light in. Okay, and also a larger aperture letting more light in means I can use a faster shutter speed and still take a picture. And so some people refer to larger apertures and lenses with larger apertures as faster lenses. Okay, so you've got a lot of terminology going on here with aperture. You've got larger letting more light in, which can be an advantage. It's a smaller number numerically, and that's described as a faster lens. Well, what does a larger aperture really mean? Well, it actually affects what we call depth of field, which I'll call just DOF. I've got a couple of images to demonstrate depth of field. This first image was taken with my 50mm lens at f2, and that's almost its largest aperture setting. Not quite, but near its largest aperture setting. And you can see it's almost fall. Tara got out the figurines, the salt and pepper shaker for Thanksgiving a little early, but here we've got a salt and pepper shaker, and the salt shaker is in focus, the pepper shaker is not in focus, and I can't even tell what the background is, just some colors and shapes. So what's happened here is I've got what we would call a narrow depth of field, where a large aperture resulted in not very much in front of the camera being in focus, just a very thin plane that's in focus. In fact, you can actually see that her shoulders are really not in focus while her face is in focus. So just a few millimeters or half an inch behind her eyes wasn't really in focus, and certainly her husband, the pepper shaker, is not in focus at all. So that's what a large aperture looks like. Now this can be helpful for isolating the subject from the background. So in this case, if I wanted to take a picture of the salt shaker, this would be better, for example, than picking a smaller aperture, because now there's a lot of other things in focus. Suddenly her husband, the pepper shaker, is pretty much in focus, not perfectly but pretty close, and I can see all sorts of distracting things in the background that take my eyes off the salt shaker, which might have been the subject. So the advantage of a narrow depth of field is I also get to isolate my subject. So going back to this page, I can see that this can help me isolate my subject by using a larger aperture, which is numerically smaller. It also enables me to use a faster shutter speed and achieve the correct exposure. So it all seems to be advantages so far. So what are the trade-offs? Well, to get a really large aperture, which is an f-stop of about f2 or f1.4 or f1.8, these are numerically very small ratios, that costs money, because to get the larger aperture, more glass has to be manufactured, so they end up being a wider, bigger, heavier lens. So this tends to cost money when you buy the lens. And then the other trade-off is that because it is a narrow depth of field, because it is less of the distance in front of the camera is in focus, a smaller, thinner plane is in focus, it can be harder to take action photos because only a small plane in front of the camera is going to be in focus. If somebody's running around, it can be hard to time that and get that to autofocus correctly in the right place. So I'm also going to put in here focus is a disadvantage of using a larger aperture. So these are some of the variables that come into play when choosing an aperture for taking your picture. Well, how do you control it? How do you choose an aperture? Well, you can't do that in the auto mode. You're going to have to use either, we've described it before as program or P mode, or an aperture priority mode. Sometimes that's AV, sometimes it's just A. And in these modes you can select an aperture. You're going to have to look at your manual and figure out what wheels and buttons you have to press to make aperture change. And when you do that, you're going to find that it affects other things too, because as you open up the aperture, you let more light in, so it's going to have to use a faster shutter speed to get the correct exposure. And when you select an aperture and you press the shutter button halfway down, it's going to meter the scene, it's going to pick a shutter speed. You can, if you go back to the video on exposure, you can still apply exposure compensation to it. When you do that, it's going to extend or reduce the shutter time by the amount that you want to compensate. But that's part of selecting the exposure. Camera's going to meter that even in these aperture priority mode or program mode, but at least it's now letting you select the aperture that you want for your photograph. So if you want to use that larger aperture to get the narrow depth of field, to get the subject isolated, or to help you speed up the shutter and let more light in, these are the modes that are going to enable you to choose that and determine that. So that's how you're going to control it. So hopefully you've learned a little bit about aperture today. I'll have some other videos on shutter speed, sensitivity, and some other things to help you put it all together and help you understand it even better.